Hi, welcome back. I'm welcoming you all to this beautiful online learning platform, Unacademy. Unacademy is the India's largest online learning platform. All of you know that. Unacademy is the India's largest online learning platform. So once again, I'm welcoming you all to this beautiful online learning platform. Now, we are happy to announce that now we are going to providing online training for the students who are going to appearing for GATE and engineering service examinations. Okay, now here your classes are taken care by India's top educators. India's top educators will handle your classes. That means toppers in IITs, toppers in GATE exam, toppers in IAS. Okay, these are the faculty and who are having a vast experience in this field. They are going to handling your subjects. Now, about myself, I have 16 plus years of teaching experience. So far, I mentored more than 60,000 students for their GATE examination. At present, I am pursuing PhD from JNTU Canada, and my specialization is VLSI design. Now, first we check how to get Unacademy learning app into our device. Just go to Play Store in your device, type Unacademy in that. After typing Unacademy, you get the Unacademy learning app like this. Here, by clicking on this install button, you will it will install Unacademy learning app into your device. See this, here are the few of the top educators from Unacademy. Tiwari sir, he is the IIT topper and he has 7 years of GATE and engineering service exam experience training, and he is the author of a book, GATE in 75 days. Next, Ankit Goyal sir, he obtained 2 times All India first rank in GATE electrical. Okay, he was awarded President of India Gold Medal in IIT Indore. Jaspal Singh sir, he is ex-IAS officer. He got All India 4th rank and he is the ex-senior faculty from MedEasy. And Sanchit Jain sir, he has a sound experience in teaching the students. He has more than 8 years of experience. So because of these things only, we are claiming that our educators are the top educators. Here are the few more top educators from Unacademy. And here there is a scholarship test going on in Unacademy. See this. So a scholarship of worth 1.8 crore plus is going on in the month of March. Now in 21st March at 11 AM the scholarship test is going on. Don't forget to use my code while writing the exam to unlock it, VRAW10. Okay, in that first 3 winners are going to get 100% scholarship for plus subscription, and top 100 winners from each branch will be given additional discounts. So these are the branches we are conducting: mechanical, civil, computer science and information technology. This test is on 21st March at 11 AM. So duration is 60 minutes of time. Okay. Now the same thing here also, 1.8 crores worth of scholarships in March. Now from this what you are going to getting is India's largest fortnightly competition for GATE, and assess your GATE preparation in 60 minutes. Challenging and original GATE questions, which is curated by the best educators. These are the eligible branches: mechanical engineering, civil engineering, computer science and IT departments. Now take it live to compete with the best and super fast and fun with All India live leaderboard. Now after this exam you can identify and improve your weakness areas through detailed video solutions. After completion of this exam, a detailed video solutions of those questions is going to be provided to you. So you can improve your weakness. You can improve your weakness areas through this. That means you have to identify your weakness areas and you should be get improvement in that. That is our intention. So next combat is on March 21st, 2021 at 11 a.m. Now there is a engineering service examination test series is going on. GATE 2020 for engineering service 2021 was curated by the best educators. All India live ranking is provided if test is taken live, and it is designed as per challenging demand for engineering service examinations. And in that 10 questions, 20 minutes of time, and the exam is on for mechanical students 22nd and 29th March, for electrical 23rd and 30th March, for civil 24th and 31st March, for electronics and communication engineering students 25th March, and for general studies it is on 26th March. Okay, now don't forget to use my code to unlock your exam series VROW10. Now elevate your engineering service exam 2021 by attempting the full length mock test. In that 150 questions, 180 minutes of time. It was on 21st and 28th March at 10 a.m. For mechanical engineering, electrical, electronics and communication and civil engineering students, this was conducted for. And there is a golden opportunity to civil engineering students crack engineering service exam with Jaspal Singh sir. Okay, join us for free test series. These are the topic. This is the exam date on test date. These are the topics. Topic wise we are going to be conducting tests. Okay, with Jaspal Singh sir. Now there is ultimate 10 SSC series is going on for mechanical engineering students. Dates 1st, 4th, 9th, 12th and 17th of March. Timing is at 10 a.m. Okay, now this is SSC series. Now in that 10 questions and 20 minutes. Even if time is not supporting you that live session to attempting, and you can write the test can be attempted even after the live test session. After live test session also you can attempt the test. Next there is electrical engineering. For that 10 questions, same 20 minutes of time, same 10 a.m. time. These are the dates for that, and you can attempt the test even after the live test session also. Same for civil engineering, 10 questions, 20 minutes. These are the dates and timing is 10 a.m. Here also there is an option after the live test session also you can attempt the exam. Now we go to GATE 2022 preparation. Start your GATE 2022 preparation every Tuesday and Thursday and Saturday at 10 a.m. There is a test. In that test for 10 questions and 20 minutes of time. 10 questions and 20 minutes of time for every Tuesday, Thursday and Saturday at 10 a.m. Okay, and it was designed for mechanical engineering, electrical engineering, computer science, civil engineering, ECE and chemical engineering students. It was curated by the best educators. All India live ranking is provided if test is taken live. Designed as per the challenging demand for GATE. Now we are happy to announce that recently we started 2 new batches for GATE. One is for GATE 2022, other one is for GATE 2023. So there is a Ascent batch going on for mechanical engineering students, GATE 2023. It was started from 22nd June 2021. Here are the top faculty who are handling the subjects in this. Next there is a Evolve batch for GATE 2022. Mechanical Engineering. 22nd February 2021 it was started. Now here are the top faculty who are handling the subjects in this. And don't forget to use my code VRAO10 during subscription to get 10% discount. Okay, the same faculty who are handling the subjects in GATE 2022, same faculty are going to handling the subjects here. Now we are moving to Spark batch. Okay, next mechanical. There is a mission DDR going on for mechanical students for GATE 2022. Now here are the top educators who are working under this. Tiwari sir, Uma Maheshwara sir, Menu Gupta ma'am, Amanraj sir. Okay, now already I given information about credentials of Tiwari sir. Now Uma Maheshwara sir is the top educator, top experienced faculty from south side. Okay, if you move outside, if you get the information about if you discuss about mechanical engineering faculty, top faculty, Uma Maheshwara sir stays in the front line. So he's the well experienced faculty, and this batch was started on 22nd February 2021. Now the intention behind to start this batch is to get every student in this batch has to get a good rank. With that intention we started this batch. Now there is a Spark batch is also going on for civil engineering for GATE 2022. This is only for English batch. This is only English batch, and it was started on 22nd February 2021. February 2021. This is going to start. Now we move to civil engineering. For civil engineering, there is a Ascend batch for GATE 2023. And this batch was started on 8th February 2021. This is the team of faculty who are working under this. In this batch, Jaspal Singh sir is there. And same team is going to handling the GATE 2022 also. It was also started from 8th February 2021. And now we move to electronic computer science and information technology. There is a Evolve batch for GATE 2022. It was started from 8th February 2021. In that Ravindra Babu sir is there, Sanchit Jain sir, Subbarao sir, Mallesham sir, Vishwadeep sir, Sweta Kumari ma'am. Here are the top educators working under this batch. And Ravindra Babu sir is the first faculty. He is the alumni of IIC Bangalore. He is the first faculty who started the online training for GATE. And now there is a Ascend batch for GATE 2023 for electrical students. Now this is the team of faculty who are handling the subjects for electrical students. This batch was started on 1st February 2021. And there is a Evolve batch for GATE 2022 for electrical engineering also. The same faculty, same team is going to handling the subjects in this. It is on 1st February 2021. Now we move to electronics and communication engineering. There is a Ascend batch for GATE 2023 for electronics and communication engineering. It was started from 1st February 2021. Now same Evolve batch for GATE 2022 for electronics and communication engineering students. It was started from 1st February 2021. Okay, 1st February 2021. Now there is a Evolve batch for GATE 2022. This time this is for chemical engineering. So my dear students, throughout India, if you observe, hardly 1 or 2 locations only training for chemical engineering is available. Now online training is available from Unacademy. So this is a good opportunity to the students who are studying chemical engineering. For them, no need to move anywhere from their study location. Just by staying at their location itself, by staying in their room, their home, you can listen the classes. You can complete your GATE training. It was started on 25th January. Now just we glance what are the different engineering disciplines available from Unacademy. There is a electronics and communication engineering department, chemical engineering, mechanical engineering, computer science and IT department, instrumentation engineering, electrical engineering, civil engineering, production and industrial engineering. These are the different engineering departments available for GATE and engineering service examinations from Unacademy. Now, there are two subscriptions, Plus subscription and Iconic subscription. Plus subscription is the basic plan. Iconic subscription is, by providing a personal coach to you, we will take your preparation to the next level in Iconic. In Plus subscription and Iconic subscription, common things is that India's best educators are going to handling your subjects. Interactive live classes are there, and structured courses and PDFs are there. Structured courses and PDFs. Next, live tests and quizzes are there. Now here we differentiate you from Plus plan to Iconic plan. Here is the difference. Once you attempt the test or a quiz, your personal coach is going to analyze your test. That is the personalized test analysis. From the analysis of that, they will prepare a proper study planner to you only for individual student, and proper study material also they will provide to you. So by following these two, every student can get success in their examination. By following these two, every student can get success in their examination. Now just we check what are the subscription cost for each and every plan. First we go to take Plus plan. In Plus plan there is a 1 month subscription, 3 month subscription, 6 month subscription, 1 year, 1.5 year and 2 year subscriptions are there. And the beauty is here EMI option also available to you. And as a faculty, I recommend the students to take minimum 1 year subscription. Minimum of 1 year subscription. For 1 year subscription, it is 30,250 rupees. After using my code, during subscription, you get it by 27,225 rupees only. 27,225 rupees only. You got it. Now, for example, if you joined outside to take a training, to take an offline training, if you joined outside, okay, at that time, generally offline trainings are going on at outside weekends and public holidays. So for your transport, to move from one location to another location, every day, that means the day on which you have a class, you need to spend minimum of 2 hours to 2.5 hours. And at the same time, for the transport, you need to spend throughout year 20,000 plus. Okay, now here we no need to pay that much. Just by that is 20,000 plus for transportation charge. Just by adding a little bit amount to that, you can get the just by paying that amount only, you can get complete your training. Just by paying a little bit amount more than that, you can complete your training by staying your home itself. No need to move anywhere. And one more important thing here is, and every week minimum you are going to saving 5 hours of transportation time. If you spend that 5 hours of time on your preparation, from each subject you can complete nearly 5% of syllabus. Okay, so my dear students, please verify these things, consider all these things. And one more important thing, India's best educators, once again giving clarity to this. Best educators are going to be handling your subjects. Okay, best educators. Once your test is completed, best educator will come and is going to giving analysis on your test exam. He will explain the topics what you completed in that. Okay, so don't miss this golden opportunity. And one more thing, at outside situation is not that much good. Okay, situation is too bad at outside. So by joining this, stay at your home, stay safely. Now there is a in Iconic plan, there is a 1 year subscription and 2 year subscription. For 1 year subscription it is 50,250 rupees. For 1 year subscription it is 50,250 rupees, and by using my code VRAO10 during subscription you get it by 45,225 rupees. Now if you check the amount, if you joined outside for training, you need to pay minimum of this much amount for offline training. In some institutions you need to pay 1.5 times or 1.6 times of this amount. Okay, now with this amount only we are going to providing training by top educators, online examinations, more number of online examinations, please take a note of it, and after completion of test, prepare detailed analysis of the test. We are going to providing personal coach to you. That personal coach is going to analyze your exam in detail. Okay, and they will behave like a mentor. They will prepare your study plan or respective material they will provide. That means we are going to identify your gaps in your preparation. Gaps in your preparation. We fulfill those gaps by providing the additional things like analysis of your exam paper, respective material, proper study planner. By providing these type of additional things, okay, we are going to fulfilling your gaps in your preparation. So my dear students, please think once, discuss with your parents and discuss with your friends and take a right decision. The decision will change your life in a good direction. Thank you. Thanks for spending your time with us. Now we are moving to our topic, MOSFET. So MOSFET is the one of the important device see MOSFET, metal oxide semiconductor field effect transistor. Metal oxide semiconductor. So here metal means we are using polysilicon, a heavily doped silicon. Oxide, it is a silicon dioxide is the default oxide layer. Now much research is going on this oxide layers. You can use HFO2, hafnium dioxide, zirconium dioxide, zirconium oxide, like that, different type of materials, and it is semiconductor. So it is either N type or P type semiconductor, N type or P type semiconductor, based on the type of the MOSFET. So basically, broadly we classify the MOSFET into two types. First one is E MOSFET, enhancement MOSFET. Second one is D MOSFET, depletion MOSFET. E MOSFET is the MOSFET E MOSFET is the MOSFET without channel. Channel has to be inverted during operation of it. In D MOSFET, channel is implanted at the time of manufacturing. Okay, and again this is classified into two types, N channel and P channel. And P channel, N channel and P channel. Now D MOSFET also again classified into two types, N channel and P channel. N channel and P channel. These are the two types classification of MOSFET. Default MOSFET is E MOSFET, that to N channel MOSFET. N channel E MOSFET is the default MOSFET. Now your complete VLSI industry is going on. Complete VLSI industry depends on these MOSFETs. In an IC, by using at present technology, we are going to fabricating more than 1 crore of transistor on a single silicon wafer. In that circuit, that much circuit, you are using so many number of junctions, so many number of transistors we are using, so many number of devices, that means logic gates we are using. Everything is designed by using MOSFET. Okay, E MOSFET, that too. Okay, now if you want a capacitor somewhere, you can use MOSFET as a capacitor. You want to use as a you want resistor somewhere, you can use E MOSFET as a resistor. Whatever you want, you can design that one in terms of E MOSFET. Whatever the element you want, you can get the effect of that element by using E MOSFET. Because of that only nowadays IC industry is growing like that. Now there are special tools for analysis of that. Okay, in that tools, in front end we have a cadence tool. Cadence tool, it is a costly tool. Even for 10 users, for 3 years, 10 users, they will charge nearly 8 lakhs to 10 lakhs. For 10 users, 3 years, they will charge nearly 8 to 10 lakhs. And another tool we have is Mentor Graphics. Mentor Graphics, tricks tool. Okay, so in IITs and NITs, you can observe these cadence tools. In private universities, rare conditions you get it, but in private engineering colleges you get the Mentor Graphics. If in any organization or institution with both the tools is that is lucky to the students. Those students are very lucky fellows if the institution having both the tools, cadence and Mentor Graphics. Okay, now later we have a separate session on cadence tool and Mentor Graphics tool, how to use this Mentor Graphics tool and how to use this cadence tool. Okay, so we have a session, later we discuss about that session also. In that session we discuss in detail about that. Next one. Now I am going to E MOSFET. In previous sessions already we completed the in detailed information about the construction of that. Now I am going to operating that E MOSFET. Okay, now once again I am going to construction in detail. So construction, So this in this there is a diffusion n plus diffusion n plus diffusion so n plus diffusion both sides. Now here this is lightly doped p-type semiconductor. This is heavily doped n plus impurity. Now PN junction is there. Once PN junction is there, we can expect a depletion region, that too it extended more towards this side. So there is a depletion region. That it extended more towards lightly doped region, lightly doped semiconductor region, p-type region. Now upon this, here we have a oxide layer. Here is oxide layer. Now I am leaving some space for this, placing the conducting lid. Throughout the region is covered by oxide layer, that is silicon dioxide. Now here on this I am going to placing metal coating. This is going to be the metal. This is metal. And one more thing, here this is going to covered by aluminum. So covered by aluminum coating. Here also aluminum is also covered by aluminum. And we place a conducting lid here. There is a conducting lid. Here also a conducting lid. Here also a conducting lid. And one more important thing is, bottom surface is total coated with aluminum by using a sputtering method. We discussed in detail about those things during the fabrication methods. Now here is a one conductor. So these are the terminals in this. This is the construction of the N-channel enhancement MOSFET. So for future reference, I'm going to copying this. Now here, this is the bulk or substrate, this is source terminal, this is a gate terminal, this is drain terminal, and this is drain terminal. Okay, and now here S is a source, G is gate, D is drain. First you should be know one thing here. The operation of this one is flow of carriers from source to drain is controlled by gate. Flow of carriers from source to drain is controlled by gate. Don't forget that. Now say this. So during the operation of this, what we are doing is, whatever the source terminal and substrate bulk terminal both are short circuited. Why those two are short circuited is there is a problem in that. That problem is body effect. To solve that problem of body effect, these two are short circuited to each other. Bulk and source, that means substrate and source both are short circuited. Okay, to solve the problem of body effect. Okay, so my dear students, please take a note of this point. So this is very important. Source and substrate both are short circuited in MOSFET to solve the problem of body effect. What is that body effect and everything we discuss in next sessions. Now, next one is here. This is going to be metal. This is metal. This is silicon dioxide layer, and this is the semiconductor. It is semiconductor. This is the region semiconductor. Now you observed or not, there is a stack metal, semiconductor, it is metal, it is oxide layer, and it is the semiconductor, MOS. So that was I am writing this. Here it is going to be metal. First one is a metal layer. So we are using metal layer is a polysilicon. Next one is oxide layer. Default it is a silicon dioxide. If other than this material, they will highlight it. They will specify that. After silicon dioxide, they are going to HFO2, hafnium dioxide. Now this is semiconductor, lightly doped p-type semiconductor it is. Okay. Now semiconductor. semiconductor. Now by observing this, see this, it is metal oxide semiconductor, so it is a MOS. This is the stack of it, a stack of metal oxide and semiconductor is there. So because of that we are calling it as MOSFET. So my dear students, please, the name itself shows the stack of it, that means sequence of the layers. Most of the students are confusing about which one is first, which one is next, like that. So don't confuse, the name itself shows the stack of that. First metal, MOS, metal, O, oxide layer, S, semiconductor. Okay, and this is the channel region. We need to form a channel in this region. Okay, later this is the enhancement MOSFET, so channel has to be inverted during the operation of it. Later in operation session we discuss about that one. So this is the overview of construction of this one, and I am writing that working also here. Its working is, its function is flow of carriers from source to drain is controlled by gate. Flow of carriers from source to drain is controlled by gate. So on gate terminal we are going to applying the voltage. Okay, this is the construction. So during operation, first we need to get a channel. To get the channel, we need to apply a voltage on gate terminal with respect to source. Okay, now one more thing, this is aluminum, sir. This is aluminum coating. This is a metal, that means aluminum. That means I want to place a conducting lid. This conducting lid has to be inserted here. Just a drop of aluminum we place there. That metal lid is dip into that. Same thing here also. Now this is SiO2. SiO2, silicon dioxide. Same thing, SiO2. Same oxide layer is SiO2. Whatever the layer, remaining layer, that layer is going to be completely covered by silicon dioxide. That is going to protect the surface of it. It is going to protect the surface of it. Okay, now I am going to operation. First in that step 1 is channel formation. Now step 1 is channel formation. That means I want to form a channel. Formation or inversion. I want to invert the channel. So for my better understanding purpose, instead of taking this MOSFET completely, you can assume source connected to bulk, and only this region I am going to be drawing now onwards. Only this portion is going to be drawing now onwards. Okay, now so I am going to drawing it. So these are the n plus regions. Now upon this we have a oxide layer. Oxide layer. For better understanding, I am taking much more oxide layer. Now upon this we are placing polysilicon. Polysilicon. So now here I am going to placing a conducting lid. Here is a conducting lid. Here is another conducting lid. Gate. It is another conducting lid. So you can assume remaining portion is covered by silicon dioxide. So this is source, gate, drain, N plus, it is lightly doped p-type substrate. P-type substrate, lightly doped p-type substrate. Now yes, say this. First I want to form a channel. Your bulk, whatever the bulk you have here, that bulk is already shorted to source. Once it is shorted to source, this is the bulk. It is shorted to source, shorted to source. Shorted to source. This is bulk. Now I am going to applying a voltage on gate with respect to source. Gate is positive with respect to source. I am taking gate is positive with respect to source, that is VGS. I am going to be applying VGS. So that too I am going to increasing the VGS value, increasing the VGS value. Okay, now here once we are applying VGS like this, that means we are applying VGS is positive. That means gate became positive. See this, gate is positive with respect to source. Once gate is positive with respect to source, due to source shorted to bulk, now bulk became negatively charged, because this total bound bulk is total surface coated with aluminum. That's why that negative charge spread like this. It is positive. That means this total positive charges are placed like this, because it is a polysilicon metal conductor, so positive charge. But in case of this, you observed here, this one, this is your oxide layer, silicon dioxide, it is oxide layer. Okay, your oxide layer is not, it is an insulator. It doesn't allow any single charge carrier through it. Doesn't allow any single charge carrier through it. Okay. Now doesn't allow any single charge carrier through it. See here. Once it is positive, negative. Now in silicon dioxide also we have charges. Once it is applied positive, now polarization of charges takes place in silicon dioxide. Polarization in this sense, whatever the negative charges here, they are attracted towards this side, but they are staying at boundary of this oxide layer at gate side, because they are not penetrate cross the oxide layer, because silicon dioxide is the insulator. It doesn't allow any single charge carrier to it. And so next here it became positive. It became positive. So positive and separation of negative and positive charges in a oxide layer takes place. Okay. Is it okay? And one more I'm going to be applying here. So once applying VGS, okay, overdrive voltage, or effective voltage, see this, we are using this one later. Now once VGS we apply like this, what happens is, it is positive, it is negative, fine. Now once it is positive here, now the oxide layer towards semiconductor, it is positively charged. Now here it is negative. Now there is an electric field directed from oxide layer to bulk side, like this side. Due to that electric field, what happens is, whatever the electrons available, whatever the electrons present in substrate, these electrons are going to be moving towards this. Electrons are moving towards that. See? Now, see this? So once VGS is applying, whatever the electrons present in this, these electrons are moving towards the oxide layer side. These electrons are coming like this, and they accumulated below the oxide layer like this. Okay, so this is the channel region. This is channel region. This is the channel region. So once increasing VGS, what happens is, so by increasing VGS, we observed increasing VGS, electrons starts accumulating below the oxide layer. below the oxide layer. That means in channel region. Now let us 1000 electrons or 10,000 electrons are accumulated here. Now can I call channel is formed? 1 lakh electrons accumulated. Can I call channel is formed? 2 lakhs electrons accumulated. Can I call channel is formed? At what condition can I set channel is formed? At what condition can I set channel is formed? See, here by increasing the applied gate voltage continuously, the accumulated electron concentration is going to be increasing like this, and at one particular value of VGS, the accumulated electron concentration is equal to the substrate majority carrier concentration. Then we can set channel is formed or channel is inverted. Why I am using the term channel is inverted is, this is the previous construction. In this is the semiconductor. Which type of semiconductor? It is p-type semiconductor. P-type semiconductor, why we are calling it as a p-type semiconductor? Why we calling it as a p-type semiconductor? Because this is the total substrate. Substrate is a p-type semiconductor. Now here majority carriers are holes. That's why we are calling it as p-type semiconductor. Next, here once electrons are accumulating, and whenever electron concentration, accumulated electron concentration is equal to the substrate majority carrier concentration. That means here previously whatever the number of, without applying gate voltage, whatever the concentration of holes is there, now the electron concentration is equal to that much. That means hole concentration is decreasing because holes are repelled away from it, moving away from it. That's why now that means this region is converted from p-type semiconductor to n-type semiconductor. That's why because of that we called it as inversion. Channel is inverted. Now I am writing that. So I'm writing that point. By increasing VGS continuously, increasing VGS continuously, the accumulated electron concentration increases. The accumulated electron concentration increases, and at one particular value of VGS, particular value of VGS, this accumulated electron concentration is equal to the substrate majority carrier concentration. Substrate majority carrier concentration. then we call channel is formed or inverted. That means an inversion layer is an inversion layer is an inversion layer is formed in p-type substrate between source and drain. Because of that, I'm calling as channel is inverted. Okay, so and the value of VGS at which channel is formed is called threshold voltage. Now the value of VGS at which, so just before we mention, so this the value of VGS at which channel is formed or inverted is called threshold voltage. VT. Threshold voltage VTH. So the definition of threshold voltage is very important. Okay, and at the same time how getting the channel is also very important. Now after completion of the channel, how it is looks like. After channel, how it is, just we now I'm drawing that the MOSFET with the channel. So this is the MOSFET with the channel. Okay, and surrounding of this there is a depletion region. There is a depletion region. Okay, so this is the depletion region. and this is n plus, this is n plus. Here is the channel, here is the channel, like this is the channel. Now, so here we applied VGS. So the value of VGS, what you are applying, source and gate. Now the value of VGS should be is VGS. So during the operation of MOSFET, always VGS should be greater than or equal to threshold voltage. So during operation, VGS is greater than or equal to threshold voltage. Okay, so far we form, this is the drain terminal. Okay, so far we know how to get the channel and what is the channel, and here this is the length of the channel, this is length of the channel, length of the channel is L, length of the channel, L is the length of the channel. There is a channel length modulation. Okay, there we discussed in detail about this length of the channel. Okay, now by keeping VDS constant, okay, we are keeping VDS constant. See this. So next, so we know how to get the channel, and now in this operation I am going to applying the first one is VDS I am keeping constant, and VGS varying, VGS varying. Now just if you observe the previous one, here once you apply a voltage drain positive with respect to source, what happens? Now for better understanding I am extending this, copying this. See this, this is our diagram. Here what I am doing is VDS VDS is constant I am keeping, and VGS increasing, varying. So here what happens is, that means I want to plot this VGS versus ID or IDSS you can take. Now keeping VDS constant, VDS constant. See, now VGS we are comparing with the threshold voltage. So you mentioned always VGS should be greater than or equal to threshold voltage. See this? Now I am applying a source connected to ground. At drain I am applying VDS. With respect to drain, source is grounded. That means the voltage we applied between drain to source, like this, negative, positive. VDS I applied on drain to source. Now what we are expecting is, this is positive terminal, it is negative terminal. Now whatever the electrons present in this, that electrons are going to be moving from source to drain. Now this is the movement of electrons. Electrons are moving like this. This is the electron movement. Electron movement. So once electrons are moving like this, automatically there is a drain current flowing from drain to source. So drain current is flowing from drain to source. There is a drain current. ID. Yes. IDS. IDS. Okay, now this current is flowing through channel. Okay, but if you observe one thing, up to VGS, in VGS, up to VT, up to threshold voltage, there is no channel. Up to threshold voltage, there is no channel. Whenever threshold voltage is applying, then channel is forming. Once channel is forming, due to the applied constant VDS, current is increasing. Now this is going to be like this. Now your current is increasing like this after this. Like this. Increasing like this. Okay, so that current is increasing like this. Like this. Yeah, so current is increasing like that. Is it okay? That is the plot for it. And what are the things available here? IDS, drain current, threshold voltage, and VGS. All these are represented by an equation, that is IDS is equals to some proportionality constant K into VGS minus VTH whole square. This is the case for VGS is greater than threshold voltage, and it is 0 if VGS is less than threshold voltage. That means if VGS is less than threshold voltage, there is no channel. Once no channel, no conduction, no current. If current is there, then IDS is K into VGS minus VTH whole square. K is called transconductance parameter. We discuss in detail about that later. Okay, now equal to also. Now, so this is the overall operation of this, and this is the transconductance of this. Transconductance plot of it. That means a plot between output current and input voltage. Okay, this is the operation of MOSFET in with by keeping VDS constant and varying VGS. Here we are varying VGS. Now you may ask one thing, sir, I am going to increasing the VGS continuously. Increasing VGS continuously. If I am applying VGS greater than VTH, then what happens? Then what happens? More channel is there. Channel is enhancing, increasing. Amount of channel is increasing, enhancing. That's why we called it as enhancement MOSFET. That's why we call it as enhancement MOSFET. And the value of, let us, this is the VTH is somewhere here, threshold voltage. Now the additional VGS what you applied is called effective gate to channel voltage. Effective gate to channel voltage. Okay, or effective gate voltage. Therefore, our overdrive voltage. So VGS minus VTH is called overdrive voltage. Overdrive voltage. Okay, sir. So that is the overdrive voltage. Is it clear? Now, this is the operation of it, or it is also called effective gate voltage. Effective gate voltage. Is it clear? Or excess gate voltage also, you can call it by excess gate voltage also. Excess gate voltage also. Okay. Now I am going to keeping VGS constant and I am going to varying the VDS. Then what happens? Just a minute. Now, so in this step 2, we are going to keeping VGS constant and VDS varying. In this, let us take case 1. So I am taking VGS 0 or VGS less than VTH and VDS greater than 0. Under these conditions, no channel, therefore IDS is equals to 0. We called it as cutoff region. Cutoff region of operation. Okay. The minimum condition to operate your MOSFET is VGS should be greater than or equal to threshold voltage. Greater than or equal to threshold voltage, and VDS is also greater than 0. Next case. B case is VGS greater than threshold voltage. At the same time, VDS also greater than 0. Now, here I am going to introducing a new point. I want to compare VDS and VGS also. Why? Because in this case, so see this. Now this is our channel. This is channel. Previously, during formation of channel, we are applying only VGS. Because of that, Your channel is constant throughout the region from source end to drain end, it is constant. Why? Because voltage at this point with respect to this point is VGS. Voltage at this point with respect to this point is VGS. Voltage at this point with respect to this point is VGS. That means throughout the channel from source end to drain end, the voltage applied is constant. That means the net gate to channel voltage is only VGS. So if VDS is equals to 0, the net gate to channel voltage is VGS only. Okay, and that too it is greater than VTH. That's why our channel is same. It is like a rectangle with neat shape. Now we are applying VDS greater than 0. VDS greater than 0. Now, so here when applying VGS greater than VTH and VDS greater than 0, the net gate to channel voltage is became is VGS minus VDS. VGS minus VDS. Now we have to compare this net gate to channel voltage with the threshold voltage. Okay, so now this is VGS minus VDS, fine. So this is net gate to channel voltage. So to get a channel, now if this VGS minus VDS is greater than or equal to threshold voltage, greater than threshold voltage, then only there is a channel. Then there is a channel. Is a channel. I will explain this one in detail. Okay, now, so I'm going to take in the same case. This is the case I am taking. Now this is a B.1. In this, VGS we applied is greater than threshold voltage. At the same time, VDS greater than 0 volts, and from this two we can write at the same time the net gate to channel voltage VGS minus VDS is greater than VTH, threshold voltage. And it can also written as, take this VDS this side, VTH this side, VGS minus VTH is greater than VDS. And we know that this is the effective gate voltage. In this case, I am taking the channel. Now this is the case. See, this is the case This is your channel. When VDS 0, under conditions VGS 0, channel is available same source, and this is a drain. This is the case when VDS equals to 0. Now when VDS is applying, so it became like this. If VDS is greater than 0 volts, now this is the case. So see carefully. Now let us assume this is source and it is a drain. At now I am taking this value VGS minus VDS. If VGS minus VDS is high value, channel is more. If VGS minus VDS is less, channel is less. Now we are applying a voltage between VDS, we are applying between this VDS. Now that meaning of that one is VDS is maximum at a drain end and it is 0 at source end, minimum at source end, and it is approximately midpoint at channel. Now your previous channel is like this. Your channel is like this, previous condition. So VDS is minimum at source end, maximum at drain end. Now from this, so at source end, this is at drain end. At source end, VDS is minimum. Source end, VDS is minimum. VDS is equals to 0, means minimum. It is minimum in this sense. Now VGS minus VDS, once it is minimum, it is going to be maximum. So it is maximum. So that means, and again, even though it is maximum, VGS minus VDS is greater than VT. Now at this end, VDS is maximum. Once it is maximum, VGS minus VDS is minimum. Even though it is a minimum value, it is maintaining with respect to VTH, it is greater than VTH. So from this, what we understand, the value of VGS minus VDS is more at source end, less at drain end. Because and less at drain end, that too it is greater than 0, even though it is less or minimum, it is greater than VTH. So because of high at source end, maximum at source end, maximum channel we get at source end, and the channel is going to be decreasing by moving towards drain end. At a drain end, channel is less. So channel is, therefore channel is less at drain end, channel is more or maximum at source end. So my intention is to show this point. to explain this one in effective way. That is my intention. Because of that I taken this much. Yeah. Now this is your channel. This is your channel. See this. See the thickness of the channel here. This is the channel here. Here is the channel here. So channel is decreasing. Therefore, channel is more at source and it is less at drain end. Drain end is less at drain end. Channel is more at source end and it is less at drain end. Okay. Now under these conditions, by increasing VDS, this channel is at this end is decreasing. So now I'm going to copying this. See this. Now, so this is source, drain. It is VDS varying. Okay. Now, this is the channel at present. Okay, channel at present what we have. Now what I'm doing is I'm going to increasing VDS. So at these conditions, this is the equation. VDS minus VGS, sorry, VGS minus VDS greater than VTH. So now once I'm going to increasing this one, this portion is going to decreasing, and after some time both are equal. Now therefore by increasing VDS, the net gate to channel voltage is going to decrease. The net gate to channel voltage is decreasing, and at one particular value of VDS, VGS minus VDS is equals to VTH. VGS minus VDS is equals to VGH. Then this value of VDS is called VDS saturation. VDS saturation. Under these conditions, your channel is different. Okay. Now, after this, see this. Now, just assume this is our channel. This is source, drain. This is your channel. In these conditions are VGS greater than VTH and VDS equals to 0. Next case, so this is the next case. Source, drain, now channel is decreasing at drain end. So that means here no doubt VGS should be greater than VTH and VDS is greater than 0. At the same time VGS minus VDS also greater than VTH. Okay, because of that your channel is like this. Okay, here IDS is 0 and here in this IDS increases by increasing VDS. Now continuously increasing VDS, and after that during this condition, so now I'm going to next slide. Under this condition, another condition we have, now source and drain end. Now the conditions here I am applying is VGS should be greater than VTH, and at the same time VDS also greater than 0. Now we are increasing VDS continuously. That means VGS is minus VDS is net gate to channel voltage is equals to threshold voltage. So VGS is 0 at source end. That's why maximum channel. VGS is maximum at drain end. Even though this is maximum, this one is equals to VTH. Once it is 0, that VGS is greater than VTH already. At this end VGS 0, VDS 0. Once it is 0 at this end, source end, VGS only. VGS minus 0 is VGS. That VGS greater than VTH. Because of that we have more channel. But at this end, by moving from source end to drain end, VDS value is going to be increasing. Once VDS is increasing, this difference is going to decrease. Because of that, channel is decreasing. Now under this condition your channel is like this. This is your channel. This is the channel. Okay, so source and drain end, this is the channel under these conditions. And at the same time you can write this one as VGS minus VTH is equals to VDS. Okay, here ID is maximum. Okay, and at the same time this is called condition to enter into saturation. Condition to enter into saturation. And also called as pinch off. We called it pinch off. Now, if I am going to increasing VDS further, what happens? See this. This is the case. Now, so this is the source and drain end. Drain end. We are going to be expecting like this. This is our drain, actual channel we have, what we have. This is the channel what we have. Initial condition, initially. Okay, now what I am applying is VGS greater than VTH and VDS greater than 0. Now VGS minus VDS is less than VTH. Previously this is greater than. Now we called it as a cutoff region. Cutoff region, we call this operation. And here IDS increasing by VDS, this is called linear or resistive region or triode or resistive region. Linear, triode or resistive region. Now, so we called it as a, this is condition to enter into saturation. Now it is VGS is less than VDS. Now VDS is 0 at source end. Once it is 0 at source end, VGS only is there. Now that VGS greater than VTH, therefore channel is there. By moving towards this at one particular value, let us say somewhere here, VGS minus VDS is equal to VTH. So up to that point we have a channel. After that VDS value substituting here, it became less than VTH. Once it is less than VTH, there is no channel. Because to get the channel, minimum net gate to channel voltage should be greater than threshold voltage. So your channel is like this. Now the channel is like this. This is your channel. And this is called, this is pinch off region. Pinch off region. And this total region is covered by depletion region. The region is covered by depletion region like this. Like this. This is covered by depletion region like this. Okay. Now by increasing VDS continuously, your length of the channel, this is length of the channel, don't forget that. Your length of the channel is constant up to VGS minus VTS is VDS, but once VDS is increasing, now length of the channel is decreasing. Only this is the length of the channel. Let us take it as L dash. Okay, now this variation in length of the channel takes place by varying the VDS. This is called channel length modulation. This is called channel length modulation. So this variation in length of the channel with respect to VDS is called channel length modulation. Therefore, now onwards this is called as a saturation region. Saturation region. Now this variation in length of the channel with respect to VDS is called channel length modulation. Channel length modulation. That's it. This is the channel length modulation. Now, based on these things, whatever the operation we observed previously, based on all these things, I'm going to plotting its output characteristics or drain characteristics. Now I'm going to plot output or drain characteristics. Okay, now so it is the plot between VDS and IDS. This is IDS, and it is VDS, IDS, VDS. Initially, the value of increasing VDS by keeping VGS constant, that means VGS is greater than VTH. Under that conditions, here what happens is it is increasing linearly like this. Once channel value is at source end, channel is maximum, at drain end it is minimum. Now once channel value decreasing like this, channel shape for small values of VDS, no much variation in the channel. Once VDS is varying in a considerable value, channel value is going to be varying, because that means resistance of the channel is increasing. That's why IDS is varying in a semi-linear manner like this. It is varying in a semi-linear manner like this, and it reached the maximum value here. So for this, it is going to reach semi-linearly vary, and finally it reached maximum value. Reach maximum value. Yes, it reached the maximum value. After this, now the value of VDS at which your channel is closed at a drain end is called VDS saturation. The value is VDS saturation, and after this it is constant. Okay, now this is at VGS equals to threshold voltage. Now by increasing the VGS, the plot is moving downwards. Let us take VGS1 it is. Here VGS should be greater than or equals to threshold voltage. Now the plot is moving like this, varying like this for different values of that. Next, plot is like this, so let us VGS2, okay, and VGS3 like that. Like that. If if you want to take the value approximated, okay, let us assume this is a VTH, threshold voltage. It is 2 times threshold voltage. It is take 3 times threshold voltage. It is 4 times threshold voltage. Okay, so this is the plot for it. And one more thing, in this plot, these are the points where your transistor is switching from one region to another region. That means it is going to maintain a constant current. So this is the locus of the points. Up to this region we called it as a linear region or triode region or resistive region. Here it behaves like a voltage variable resistor. Voltage variable resistor. And this region is called pinch off or active region. Pinch off or active region. If you are increasing VDS continuously like that, your channel is completely filled by depletion region and breakdown takes place at the channel, more current is flowing, then it is going to be damaged. So at that time your current is increasing suddenly like this. We don't want that. 99% we are not moving that condition. And in this region it behaves like a voltage variable resistor. In this region it behaves like either on switch. So you can use this one as an on switch, or you can use this one as an amplifier also. Okay, so these are the regions of operations. These are the transfer characteristics and output or drain characteristics of the MOSFET. Okay, so my dear students, next session we discuss about current equation for IDS, okay, and channel length modulation. So these are the topics next session we discuss. So I'm thanking one and all for spending your valuable time with us. Thank you very much. Don't forget to use my code VRAO10 during subscription. Hit the bell icon for getting notifications. Don't forget to subscribe us. Please give your valuable comments on YouTube and join our Telegram group for getting latest updates on our upcoming videos. Okay, now thank you very much. Thanks for spending your valuable time with us. Okay, once again I am welcoming you all to this beautiful online learning platform, Unacademy. Okay, thank you very much.